you are going to set up a box, and it needs to be a little bit long. I always forget exactly how many boxes I'm going to need, but I know that x plus 2 is going to go down the side. I think I need 4 boxes. I might only need 3 boxes. I just add more boxes if I need more boxes. X plus 2 is the divisor. So division is the opposite of multiplication. So over here, when I divided, my quotient was 205. Isn't 205 times 4 820? So right, doesn't multiplication give you back at the beginning of your division problem? So I'm going to put my divisor down the side, and my quotient is going to end up here. So this is going to be my quotient. So your quotient times your divisor gives you your dividend. So your dividend is going to go inside your box. So I'm just going to write over to the side that your dividend ends up inside the box. Your dividend ends up inside the box. Your quotient ends up here. Your divisor is here. When you multiply them together, you get your dividend. Just because that's the inverse of division. 205 times 4 gets me back to 820. X plus 2 times my quotient will get me back to my dividend. All right, so your first step is you make sure that your dividend is in standard form. You don't want to be using like a scrambled up dividend. So my dividend is in standard form. I'm going to put the first term of the dividend inside the box. I'm forcing myself to get the dividend. What number has to go on top here so that when I multiply these two together, I get 2x cubed inside the box? It has to be 2x squared. So you find the first term of your quotient. Your first term of your quotient is 2x squared. So now, do you see a box that you could figure out? It's like a puzzle. I can figure out this bottom box, right? Because I'm just going to multiply 2x squared times 2. So what goes in the bottom box? 4x squared. So you're doing some multiplication along the way. All right, so now let's read this again. The dividend has to end up inside the box. What's the second term of my dividend? 5x squared. What do I currently have inside my box? 4x squared. So I'm going to put in this diagonal whatever is going to make this add up to 5x squared. So what would I need to add here so that this is my dividend? If I have 4x squared, I have to add 1x squared to get to 5x squared. So I'm just going to write a 1 just to emphasize that I have 1x squared in this box, because 4 plus 1, now this is building this dividend, right? So far I have 2x cubed plus 5x squared. So if I have this box, I'm going to do this step next. What goes up here in my quotient to make x squared? X. So the second term of your quotient is plus x. So now you're going to repeat. So I can do this box now because I have the top number and the side number. So what is this box going to be? 2x. All right, what do I want? Remember, inside the box, I need to build my dividend. I currently have 2 x's. How many x's are in my dividend? Negative 3 x's. Whatever I put here has to add up to negative 3 x's. I have a positive 2x. What do I add to get to negative 3 x's? Negative 5x goes in that top box. Negative 5x. Whenever you have this position, you're going to do this position next. So what would go up here in my quotient? I'm trying to get to negative 5x though when I multiply. So I need a negative 5 up here, and that is the last term of my quotient. I should have circled it a little bit further over, but. All right, so now I do this bottom box. What do I get? And what did I want to have as my dividend? Did I want negative 10? Or I really wanted a positive 4 to show up. So your remainder is going to be whatever goes here to get you up to that positive 4. So what would my remainder have to be? 14. How do I know it's the remainder and not the next term? Well, can I go past a constant? So if I try to do something here, what would multiply by x to give me 14? I can't do it, right? Because I'll end up with like 14 x's. So your remainder is 14. Once you get to the end of your trinomial, right, you can't go past a constant. So your remainder is 14. If you just want to write it as R14 at the top, that would be a good enough answer. This has some significance once you get to use division later on, but that's my quotient, that's my remainder. So you just did division. So it's a lot of steps, but it's the same set of steps over and over about 3 times. So let's do another one together. So you're going to write your divisor on the side of your box. I think this one is going to maybe be the same length of a box. I might need another box at the end, but my x minus 1 goes down the side. I'm going to double check. This is my dividend. It's in standard form before I get started. And my first step is I put the first term of the dividend in the top left box. I'm trying to make the dividend. So what goes on top? See, you have to know how to multiply to do division. All right, so you do the top. Yep, 2x cubed, yep. Once you have a number on top, you can multiply to get the lower left box. So what number would go in the lower left box? Yep, negative 2x to the third. Okay, now I look up to my dividend. I need to get 3x cubed, but I currently am in the hole. I have negative 2x cubed. How much do I add to that to bring it up to 3x cubed? 5. So that goes in the diagonal across from it. So 5x cubed plus negative 2x cubed adds up to what I want it to be, 3x cubed. You can kind of check as you go that you're adding up to the right things. So now once you have this step, you're going to do the top and then inside the box again. So what would go at the top? What times x is 5x cubed? 5x squared. So what goes in the bottom box that I can fill in? Negative 5x squared. So it's here, right? Because I'm multiplying. So I get negative 5x squared. And now I do the puzzle. I'm trying to get to negative 2x squared in my dividend. What am I missing from this diagonal that will get me back to negative 2x squared? Positive 3x squared. Yep. So 3x squared is that number. Now see if you can do the top and the bottom on your own, this next step. Just do one next step. What would go up here and what would go down here? Then this is going to be just a little tricky step in between here. So this is plus 3x and minus 3x on the bottom, right? All right. I don't see any x's. I go from x to the fourth, x cubed, x squared, and then I go down to 8. So what you might want to do is if you're missing a term, say that you have 0 of them. See how I have 0 x's? I go from x squared down to a constant. I have 0 x's. So if I currently have negative 3 x's, what do I want to put here? I want to get to 0. So I need positive 3 x's to add up to 0. That's a tricky step because there isn't 0 written in the problem. All right. What's my last term of my quotient going to be? What is it? No, hold on. What times x is 3x? So I need to do plus 3. That's the last term of my quotient. This right here is my quotient. How did I know I get to the end? I hit a constant. Hitting a constant is like, that's the end of your quotient. But I might have a remainder. So what do I put down here? I put negative 3 down here. See, I did need one more little box here. No big deal. All right, what's my remainder have to be? Because I wanted to get to positive 8, I only got to negative So what's my remainder? 11. Positive 11, because 11 and negative 3 would add up to positive 8. So 11 goes in this box, but I can't go any further with my quotient, so I'm going to write that I have remainder of 11. And then at the end, you could check that you have the right answer. All of these terms should exactly add up to your original dividend. So quotient times divisor is your dividend, and then we have a remainder. So it's a puzzle. I think it's kind of a cool puzzle. It envelops everything that you've done. Addition, subtraction, and multiplication. And I think that it's understandable, right? Because you have done a lot of multiplication using the box method. Here's where it's going to be helpful for us tomorrow. It says use division to determine whether a polynomial is a factor of another polynomial. How do I know if something is a factor of another number? What does your remainder come out to? If it is a factor, the remainder should be 0, right? 205 times 4 is exactly 820. The two that we just did had remainders, right? So they were not factors. So here's a problem. I have x plus 3, and I want to know, is that a factor of this polynomial? And this is not a factorable question. I don't know how to factor that. I don't have any strategies. It's a cubic function. So what I'm going to do is I'm going to do division, and I'm going to see if I get 0 as a remainder. So I'll set it up for you. I'd like you to try this one on your own and see if you can get 0 as a remainder or if there's another remainder. So put x plus 3 here and put x cubed in that top box. See if you can go through the steps and come up with a remainder of 0. And I honestly can't remember if it has a remainder of 0, so I will check. It should come out to a remainder of 0. Did we get close to it? All right, the second step. Okay, well, the first step is that this is x squared. You do that part okay? And then this is 3x squared. I'm trying to get to 7x squared. So I needed 4 of them in the next box right here. 4x squared. Thank you. So there's my 4x squared. Now I do the top of the box again, right? I think if you do, 10 of these on your own, it'll start to make sense. Well, I can't do this box yet, right? I don't know what to multiply to get this box. I have to do this before I can do this, right? If you just try. All right, what can I do? So I know that this has to be 4x. So plus 4x gives me 4x squared. That gives me 12x down in the bottom. I'm trying to get to 5. And if you have trouble doing this in your head, write an equation for yourself. I currently have 12. I need to add something. I need to have 5 as an answer. So it's actually negative 7. So I need negative 7 x's. So negative 7 is the last term of my quotient. And then I would get a negative 21 down here. This is the first time that this has happened. This negative 21 matches this negative 21. There's no remainder. So answer the original question. Is x plus 3 a factor of this polynomial? Yes. Yes, it's a factor. There's long division and there's synthetic division. The reason I'm not showing you other methods is because for Algebra 2, one method is enough. I am happy to show you a couple other methods, but the reason synthetic is the shortcut, but you can't use it in every situation. You can only use it when you have a quadratic or a linear function. So like, why teach you something that's a shortcut, but it only works some of the time? I think one method. If you want me to teach you another method, I Could. So x plus 3 is a factor because why? The remainder was 0, right? So I didn't need a remainder. I'm just going to put a 0 there. So the remainder was 0. And it says, if it is a factor, find the corresponding 0. Corresponding 0, that's x-intercept, right? So if you wanted to write that down, the 0 is when x equals -3. This is going to be your flashback to Unit 3, which we're going to talk about tomorrow, right? How do you take factors? X plus 4, x minus 11, and find the zeros, the x-intercepts, -4, +11. Does that ring a bell? It's good to review this week because it's on the final exam, kind of as a big idea. How do you find x-intercepts of a quadratic? All right, so take a look at page 60, is it 607? 607. All right, so I'm going to have you try number 1 on your own. Is that a factor? But number 2 is going to be a little bit different because number 2 has a 3-digit divisor. So I'd like you to try example 1 and then pause. I'd like to check that you've done example 1 correctly before we move on to example 2. We're going to do example 2 together. So this is page 607. X minus 2, is that a factor of this original polynomial? So I'd like you to try example 1 on your own. It's just asking you, is it a factor, yes or no, and then you have to justify. I was trying to make this video here. So here's my answer to example 1. Pause it if you need to try it yourself. Okay, so I'm going to put x squared plus 2x plus 1 down the side of my box. So you're going to have a 3 by whatever box. I don't know how many spaces I need. Same process, a longer diagonal. You put the starting term up at the top. Does anyone like this yet? It's a puzzle. It's like a puzzle. I think it is a cool puzzle. It's a math puzzle. Oh, this is torture? No glint of fun? When you get to the end and you don't have a remainder, isn't that so satisfying? Like, some of you know it. You just don't want to admit it. All right. You want to go to Spanish next semester? Oh, you mean this from this class, block 2? Oh. Darn, I was hoping some of you might like this puzzle. Okay. No. Division is the hardest so far? Okay, well, that's not bad. 1 out of 8 concepts so far. It's not bad. We still have 4 days to practice it. I put a 2x squared on top, right? So this is 2x to the 4th, so this is 2x squared to get to x to the 4th. Guess what? On this step, you just have to fill in both of these boxes that go down. That's not that much harder. So go ahead and multiply. 2x squared times 2x is 4x cubed. 4x cubed. And then you've got a 2x squared. All right, I'm going to look again at my diagonal here. What has to go in the circle? Because I'm trying to get to what? -1x squared. I'm currently at positive 4x squared. So what has to go here to get to -1x squared? -5x, or sorry, x cubed. I'm saying x squared, I mean x cubed. -5x cubed goes here. Oh, it goes here. So what times x squared will give me -5x cubed? -5x, you got it. So now go ahead and multiply down underneath what would go in this box and what would go in this box. And here's the step I wanted to show you about the longer diagonal. So let's see, I'd have -10x squared and -5x. How long is the diagonal this time? It's 3 boxes long. See my diagonal? My diagonal has x squared terms sitting in it. of a 0? I have 0x squared. So let's go back. I have negative 8 of them. What goes in this box? Positive 8 of them, right? Because I need to get to 0. Tricky. I shouldn't have thrown that extra twist in this problem. I think it was hard enough with the triple diagonal. More of a bonus type question. All right, does my diagonal add up to 0? Yes, it does. So what goes on top? No. Right here gets multiplied by this. So this is an 8. So plus 8. I know that I'm at the end of my quotient now, right? That's my quotient. I need to figure out if I have a remainder. So this is a two-step remainder. I've got, what, 16x's here and 8 here. 16x and 8. I'm just going to circle my diagonals in a different color. So this pink diagonal is going to have maybe a remainder. And this green diagonal might also have a remainder. So I need to double check both things. How many x terms do I need to have? 4 of them. How many do I currently have? 11 of them. So I'm thinking the number 11 in my head. How do I get to 4? Negative 7. So I really have a remainder of negative 7 x's. It's okay to have a remainder that is not a constant. What goes in my green box? I'm currently at 8. And what did I want to have? Negative 2. I'm currently at 8. So I need a negative 10 to get to negative 2. So you have a two-term remainder of negative 7x minus 10. So more of a bonus question for 2 reasons. You had 3 terms here. That makes it a little bit more challenging. I was missing a term here. So 2 challenges in 1 problem sounds like a bonus question. I think you guys could do one or the other, but not both in the same problem. All right. I want to do a couple more practice. Let's see. I'm going to skip for now example 3 and example 4 about the volume problems. I want you to just try a straight up couple problems on your own. I'd like you to try 5 and 6. I think 5 and 6 are pretty straightforward questions. If you could do 5 and 6 like a quiz, then you know that you got what you needed to out of today. So try 5 and 6. If you got them, just keep moving on and try 7 and 8. But some of you are probably just going to be able to do 5 and 6 today. And try 5 and 6. 5 and 6. 5 and 6. Yeah. How about after we do our little game at the end? You're trying 5 and 6. That's the answer to number 5. That's the answer to number 6.